So here we are, we're going to try to come up with some values, and you see the equation up here. So I want to first find out what because we're given the angles, but we don't know what these points are, so we don't know what the R value is. So I'm going to make a table. And I know 0, I know pi over 6, I know 5 pi over 6, I know pi, I know 7 pi over 6, and I know 11 pi over 6. So I'm kind of running out of room on there, but I'm going to be finding those. So if I know the 0 is the angle, 2 times 0 is 0, so the cosine at 0 is 1. So I know that r squared equals 1, so my r also equals 1 in that case. If I'm finding the pi over 6, 2 times pi over 6 would be 2 pi over 6, or pi over 3, and the cosine at pi over 3 is equal to, cosine is the x value, that'd be equal to a half. And so r squared is equal to half. Square root of that, I get the square root of 2 over 2 for that one. When I do 2 times the 5 pi over 6, I get 5 pi over 3. And the cosine at 5 pi over 3, cosine is the x, I get negative 1/2. At 5 pi over 3 would be positive half. And again, I get r squared equals a half, so square root of that, I get square root of 2 over 2. When I put in pi, 2 times pi is 2 pi, and 2 pi is the same as 0. Cosine at 0 is 1. Square root of 1 is 1. And at point E, I am at, what angle is that at E? 7 pi over 6. So 7 pi over 6 times 2 gives me 7 pi over 3. And let's write 7 pi over 3. We know that's the same as pi over 3, just another lap, because 6 pi over 3 is 2 pi. So we're doing a whole lap, and then we're going another pi over 3. Cosine at pi over 3 is a half. Square root of that, square root of 2 over 2. And we also know at 11 pi over 6, if I multiply that by 2, I get 11 pi over 3, which is the same as 6 pi over 6, or 6 pi over 3, which is 2 pi, plus 5 pi over 3. So that's just a lap. And then my cosine at 5 pi over 3, we had that answer before, and that's the square root of 2 over 2. So these values are all at square root of 2 over 2. This one's at 1, and this one's at 1, because our r's aren't negative, because it's out there at that angle. Perfect. All right, so I got all those values. Let's go down here, make myself a little bit of room. And it says, determine the polar equation of a circle that has a radius 6 and a center at the polar coordinate 0 pi. So if I, slow it up. So if I have my rectangular coordinates, or my polar coordinates even, doesn't matter, and I'm out there at angle pi, and I'm at 6, and my radius is 6, that's what my graph is going to look like. So what I'm going to do here is I'm going to determine the polar equation for it. We know this coordinate, and we know this radius. So I'm going to say that a squared is equal to r squared plus r squared sub o minus 2 times r sub o times the cosine of theta minus theta sub o. And let's plug some values in here. We have, this is 6, and we also have that r squared. We don't know that one. We do know that the initial one has a radius of 6. So 2 times r times 6 times the cosine of theta minus pi, because we have the original pi. So I put that in there. And it appears to me that I can simplify this 36 and this 36 go away. So I'm left with 0 equals r squared minus 12r times the cosine of theta minus pi. And let me do this where I put r squared on this side, which means this would be positive 12 cosine theta minus pi. I think I can divide the whole world there by r to get an r by itself. And I believe that is an equation in polar form. No x's or y's there, and just an r equals. So I think I did it. All right. So now we can talk a little bit about some 9.7 and tips for graphing. Generally graphing from 0 to 2 pi using intervals of pi over 6. Make your life easy and test for symmetry, so you don't have to test so many points. You can only, if you have symmetry, you can test half as many points and still get the same graph. The x-axis symmetry, if you substitute negative theta in for theta, you're going to yield the same equation. Y-axis symmetry, you substitute theta in for negative theta and r in for negative r, and you get the same equation back. That's kind of nice. The y-axis symmetry, if you substitute in theta for pi minus theta, you get an equivalent equation. And the origin symmetry, if you substitute r for negative r, you're going to get an equivalent equation. All right, some of those make your life easier. So let's go ahead and do a little bit of this graphing of this lemniscate. And I'm going to test some points. R equals 2 plus 5 cosine theta. And I'm testing some values between 0 and 2 pi. And I'm going to try, let's start at 0. So, yeah, r and a theta. At 0 degrees, I get the cosine of 0 is 1, so I get a 7. And then I'm going to try at pi over 6. And the cosine at pi over 6 is root 3 over 2. So I get 2 times 5 root 3 over 2, which is 10 root 3 over 2, which is 5 root 3. Let's simplify that to 5 root 3. And let's try another one. Let's do pi over 4. So the pi over 4 is root 2 over 2 times 5 would be 5. 5 root 2 over 2 plus 2. And that's 2 plus 5 root 2 over 2. And let's see if I can find a couple of these values. So this first one was there. At pi over 6, we said we were at 5 root 3. I'm going to get that as a decimal. Clear 5 root 3 equals 8.66. So 8.66. And let's see here, if I go 5 times root 2 divided by 2 plus 2 looks like 5.5, about right there. This point gives me some grief here. Let me see there. Looks like 5 square roots of 3. Maybe I did that wrong. Let's try that again. Cosine at pi over 6 is the square root of 3 over 2. So I got 2 plus 5 square roots of 3 over 2. And, oh, I times instead of added. That's why that point is off. So I'm going to go 5 root 3 divided by 2 plus 2. 6.3. That seems a lot better. Kind of smooth that out a little bit. And just for the fun of it, let's go to pi over 2. So if I do, the cosine at pi over 2 is 0. 5 times 0 gives me 0, and so I get 2. And then just for the fun of it, let's put in, I don't know, let's put in, let's go with 2 pi over 3. And I'm going to pause here because I'm going to run out of time, so I'm going to do a whole bunch of points. So it appears as if after graphing a bunch of points here and finding a bunch of points, that my graph is going to end up like this. And notice that if I want to do that testing for symmetry thing, it's going to end up being symmetric to this, what we used to call the x-axis, and now we're calling that the polar axis. I'm going to do the same thing here with a bunch of values. You do the same. Well, this one's kind of interesting. When I found a bunch of points, I get stuff that looks kind of like this. So I'm going to do, looks like that. And then I did pi over 3, which is out here, and I got that. And my graph would look like this. And I'm like, that doesn't seem right. So I went in and I found another value. So if I go in here and put pi over 4 in here and multiply that by 2, I get pi over 2. And the sine at pi over 2 is 1. And so I get another value out here at 8. When I didn't have that value, my graph looked like triangles. But when I put that value in there, it doesn't. So just another reason to check some extra values, because they shouldn't be straight line edges. So then what happens when I go to out here at 2 pi over 3, I'm going out the negative, because 2 pi over 3 is out here. 2 pi over 3 is out here. But I'm going out the negative direction, so I get a negative 6.9 out here. So my